In this video, we will look at how the gas holders were made for the gasworks. The gas holders are right at the end of the process, storing gas ready to go into the distribution network. Note the term gas holder is used, not gasometer, which is the gas measuring device contained in the building just before the gas holder in the process. Gas holders come in all sorts of shapes and sizes. Here we have a spiral one, where the different sections rotate as the gas holder fills and empties. The diagonal stripes on the side are rails, which go through roller guides mounted on top of the section below. A common alternative design was the column-guided type, here on the left, where the tank segments move up and down vertically with rollers that run on rails bolted to the inner face of the columns. On our layout, we have two gas holders from different era to provide interest. The larger one is a column-guided type, the smaller one on the left is a spiral type. They provide the scenic break for the fiddle yard, as can be seen on this planning view. Let's first look at the smaller one. The design was based on this drawing, stamped Firth Blakely, showing a plan view. On the right side of the plan, you can see the plate pattern for the crown. This was used to design the rivet lines that connected the crown plates together on our model. Here is the elevation. Note the spiral guide rails on the upper section, with handrails round the top. Also look at how the ladder on this section is split when it passes over the spiral rail. On the lower section, there is a walkway at the top, providing access to maintain the roller bearings in the spiral guides. On our model, we have added some support columns to make it a little more interesting. Henry Boucher had already made most of this model, but it needed completing. The model was made from a plasticard skin wrapped around a paint tin, which happened to be the right diameter. All of the rivet detail for the tank side plate work had been carefully punched into the wrapper, and it was much too good to discard. A labour of love by Henry. He then got stuck building the roof, which is a dome segment made from plasticard moulded over a wooden former, but he never completed this. To complete the model detail, components were required for the rivet lines across the crown, the rail guides, and the handrails. All of these were designed in CAD and then 3D printed. To make the crown rivet detail, we took the drawing and scaled it in the CAD system to the required size and then drew on the plate pattern as seen on the right, shown in blue. Based on this, we then designed 3D models for strips of rivets for each radius of plate join and standard length straight strips for the radial plate joints. These are on the left. Looking in more detail, you can see the rivet strips in blue, with the rivet heads moulded into the surface. The rivet strip sections were then assembled into frets for 3D printing. The handrail support detail required an angle iron section that slotted in under the walkway halfway up. Multiple copies of these were 3D printed. Here is the finished model showing the plate rivet detail on the sides, which was all handmade by Henry. The ladders are MSE signal ladders. In more detail, you can see the guide rail on the upper tank, which runs through the guide rollers at walkway level. Earlier we pointed out the ladder arrangement to clear the guide rail. This has been reproduced on the model. The view from on top clearly shows the plate joints and rivet detail on the crown. The blob in the middle of the crown is some sort of air valve and was copied from a photo. Now let's look at the large gas holder. During our planning sessions, the volume of the gas holder was represented by the white plastic tub next to the viaduct. The retort house is represented by the cardboard box. Henry and others had collected a number of drawings relating to double-lift column-guided gas holders made by Firth Blakely. This top view shows columns spaced radially at 30 degrees round the perimeter of the tank. The overall diameter of this tank was a little too big for our site, so we scaled it down by 25% but kept the height the same. As before, you can see the crown plate pattern on the right of the drawing. The elevation shows lots of interesting detail, in particular how the columns are put together. They were made with inner and outer flanges linked by crisscross lattice, all riveted construction. On the lowest section, you can see the plate pattern with large plates. On the upper sections, the plates are much smaller. There is a walkway on the top of the lower section, which has to wiggle its way around the columns. To hold the columns in place, there are horizontal lattice girders, and the tensioning rods or wires are shown. Note where the rods cross, there is a boss to hold them in place. At the top of each column, there is a finial with a spike on top, presumably a lightning conductor. We decided to build the large gas holder entirely using 3D printed parts. The first step in the exercise was to build a CAD model. Whilst this looks complicated, it breaks down into relatively few component parts that are replicated 12 times radially to give the whole gas holder. For each lift, there were wall sections in green, columns in yellow, and beams shown in red. Each of the components were detailed with ironwork and rivets represented as accurately as possible. To the left is the lower section column. The lug at the bottom and the hole at the top of this section are to aid locating adjoining sections. On the right is the top section with finial and lightning conductor, for which we used a very sharp pin to discourage people from leaning across the top of the model. Fine detail parts like this were printed using Shapeway's Bureau service, using a material known as frosted ultra detail. The tanks were modelled as 30-degree segments, with locating lugs at the edge of each segment to ensure an accurate join to the next. These need to be strong, so we chose to print these in a nylon material, which was laser sintered to produce our models. This gives a surface finish which is slightly rough, often compared to a Trebor mint, which was fine for our purposes. One problem we did encounter was assembling each of the walls exactly round, as they were quite large and had to sit accurately within each other and the frame. To achieve this, we made a frame for the base, with locating lugs for each wall segment and holes for the column bases. The frame was made up in small pieces for fabrication, and each piece is joined with a locating lug to ensure accuracy. This allowed us to assemble the tank sides with the precision we needed. The crown was also designed in 30-degree segments. There are upstands with rollers on them on top of the roof to locate with the vertical guide rails on the columns. The design of the walkway was fiddly and complex. It had to fit snugly along the top of the bottom section and step out round the vertical columns. The design of the walkway was a slatted surface supported by angle irons. The railings are attached to the edge of the walkway. Each of the components was developed into a 3D model and then printed. Before committing to printing the whole structure, we produced a test section with an example of each component type to test for fit and ease of construction. Once happy with the design, the 3D print was made and the model built. Sounds easy, but actually took rather a long time. It's a very big model, but well worth the effort, as the following photos will show. The walkway wiggling round the column. The specially sharpened pin as the lightning conductor. The handrails and ladders. You may recall mention of the boss, where the tension rods cross. Here it is. And of course it has a phoenix on each one. That concludes the presentation about the gas holders. Thank you for listening, and we hope it was of interest to you.